We're going to work problem number 7.8 in this Excel example. So today, full-time college students report spending a mean of 27 hours per week on academic activities, both inside and outside the classroom. Assume the standard deviation is 4 hours. So 27 is the mean, 4 hours is the standard deviation for the population, which is defined as the number of hours spent on academic activities. Now, if you select a random sample of 16 college students, what is the probability that the mean time spent in academic activities is at least 26 hours? Okay, so let's set this up. And remember, the probability what we want is not for one student, but for the average of these 16 students. That's what makes it a sampling distribution problem. Okay, so here we are given, we define first X, hours per week spent on academic activities, and the mean is given as 27 hours, and the standard deviation is given as 4 hours, and the sample size is 16. So in that case, okay, mu sub x bar will be 27 itself. Sigma sub x bar is sigma over square root of n. Okay. Now we want the probability of 26 hours. 26 hours is what we want. At least 26 hours. So 26. Now find the z value. So it will be x bar minus mu divided by the standard error, not sigma, but sigma sub x bar, sigma over square root of n. So that gives us minus 1. Now we can go to the normal table. Okay, and minus 1 is 0.1587. So 0.1587, that's the cumulative distribution. That is 26 and below. But what we want is probability for x bar greater than or equal to 26. Okay, so which means we need to go 1 minus that. So that's the answer. Now we can of course use Excel functions. If we want to use norm.dist, okay, now x bar is 26. Okay, the mean is 27, and the standard deviation is actually standard error because we are using x bar here. We want the probability for x bar. And then we have to have comma 1 for cumulative distribution. Okay, we could use norm.s.dist as well because we already have the z value, comma 1 for cumulative distribution. Of course, what we want is the opposite of cumulative, the complement of cumulative, then we go like that. So that's the answer to A. Now, B is there is an 85% chance that the sample mean is less than how many hours. So here we are going backwards. We are given the probability and we want the x bar value for that probability. So we want the 85% chance that the sample mean is less than a particular value. So that means this 85% is the cumulative probability. So given probability is 85%, that is the cumulative probability. So z value from the table, so go to z value, look for 85% inside the table and look and read the z value from the edges. 85 is here. It's in between 1.03 and 1.04. So we can use 1.035 as a midpoint. 1.035. Then this is x bar. So this will be x bar, not x. So the x bar would be mu of x bar plus the z times sigma sub x bar, which is sigma over square root of n. So that's the number of hours that 85% of these students would spend at least 28 or less than that. And of course, we can use Excel function for this, which would be norm.inv, okay, 85%, and the mean and standard deviation from there. Okay. Or we can find z using norm.s.inv, and for 85% probability gives us the z table value. Okay. And then x bar is mu plus z times sigma. Now question C is, what assumption must you make in order to solve A and B above? Okay. Now, if the original population was normal distribution, then you don't need any assumptions at all, because x bar will be normal no matter what. Now, we don't know that. We don't know what distribution the original population follows. So, for x bar to be normal, we need at least 30 in sample size. Since sample size is 16, then for us to be able to use normal distribution for x bar, and the population must also follow normal distribution, because you need 30 or more for us to not make any assumptions about the original population. So x, the hours per week on academic activity, okay, follows normal distributions. That's the assumption that we have to make. Now D, if you select a random sample of 64, then there is an 85% chance that the sample mean is less than how many hours. So this time n is 64. Okay. Then our sigma sub x bar will be sigma over square root of 64, not 16. Okay. So sigma sub x bar. Okay. Now we want x bar value. Okay. Same 85%, so we can use the z table value from here. So it will be mu plus z times sigma sub x bar. So that is the x bar value for which 85% of the students will fall. Now in this case, for D, we don't need this assumption, because sample size is 64. It's a large sample, so x bar will follow almost close to a normal distribution irrespective of what the original population distribution is. Now of course we want to use the norm.inv function, then it'll be probability is 85%, mean is 27, and sigma sub x bar is 0.5.